biodiversity of solutions. Every solution except a normal forest, every solution has a long-term side effect. If we plant trees, it's not enough. It's demonstrated by so many different people. Just Google it, you'll see it. That covering all the useful surface of land on the planet with trees will not capture the amount of CO2 and equivalent that we need to capture. We won't clean up. Okay, it's not enough. And because of this statement, some people have turned to, so let's not plant trees then. It's useless. Let's just focus on zero emission. The thing is, planting trees right now is not to resolve the solution. It's to slow down the cataclysmic cascade, the amount of catastrophes that happen more and more frequently. Okay, now planting a tree has a certain potential, but the Superforest program in AtmoCare, that's one of our main in-house program, is a step above permaculture. Some of you have heard about permaculture, some not. Doesn't matter. Basically, instead of just planting trees, what we do is we rebuild the soil. And our first test a few years ago showed an increase in growth speed. It really grows fast. So 238%, so 2.38 times the speed of growth of the younglings. Then it stabilizes, okay? And they reach 20% higher size than the monitor groups. So they grow faster, they go a bit bigger over time. And that's because we don't just plant trees. In a soil that was deforested, for example, okay? So the forest industry went with their machinery, took all the plants, all the trees and everything, and it killed the soil. It removed the mushrooms, the bacteria, the insect population, the wildlife. It destroyed the ecosystem, and now the only thing that grows is weak, small trees or weeds. Congo weed is one of the common ones, but there's many different more. So all these weeds, you have these fields covered with weeds, and forests cannot really thrive there. So it's not enough to just plant trees there. We have to re-aerate the soil. It's compacted. We have to break the ground. We have to bring air back. We have to bring the bacteria. So we have to bring the insects in there. Undergrowth, so basically bajo bosque, the undergrowth, the different kind of plants below the trees in a forest, at least 5 species to have biodiversity, and the mycorrhizal mushroom and the insects that will all go there and give life back to the ground. And then we plant trees, but we also put mulch. Mulch is a big, big influence. Mulch is organic matter, like chips of wood or leaves and stuff that settle on the ground. So when it rains, it acts like a little sponge of organic matter that prevents all the water from evaporating when it's sunny or when it's too hot. So it keeps the water much longer, and the rebuilding of the ecosystem, the life at the bacterial level and at the insect level and at the plant level, all of this together is like a super pampered, cared for ecosystem, and the plants thrive like crazy. It's like magic. It's a completely different thing. So instead of having an adolescent forest after 10 years, we could have it after 3 years. And that means that immediately we become efficient at carbon capture. Also, we do a mix of our trees. We take 5 species of trees, 3 that grow extremely fast and die young. Trees that grow fast and also die young, when a tree dies, half the carbon goes back to the atmosphere through putrefaction. So the carbon recombines with oxygen, goes back to the atmosphere, and half the CO2 stays in the ground, okay? So if a tree dies young, it's not sequestering as much carbon because half of it goes to the ground. But during its life, it grows so fast, it captures double the carbon of a normal tree, of the slow-growing trees. Therefore, it captures double and very quickly puts half of the double to the ground and half back the atmosphere. It means we've captured and sequestered in the ground the same amount as a slow tree, but the slow tree will do it over 30, 40, 50 years, and we need to do it now. So we start with very young, very quick growing trees that will grow extraordinarily fast and will die within 15 to 25 years. And then the other trees take space, 2 and then maybe 3 species, or if we just replant. There's so many ways, okay? But that's what allows an ecosystem to be perfectly built. Once the insect ecosystem rebuilds, and we're going to encourage it, we're going to put pollinators and stuff like that, then we'll need a bird population. In some countries, even a bat population. So we will have to grow birds and bats also and re-inject them into the ecosystem. So a super forest takes care of absolutely every aspect and every level. And that's why our forests grow so fast. And the test that we've done, thanks to Jonathan Denis Vincent in Quebec, Canada, what we've done is usually we're in zone 5 and the plants grow like in zone 6 in the heat. Okay, so the ground, when winter was ending, the ground started to generate its own heat, which allowed the plants to start growing immediately. And we have photos of these flowers and these plants growing through the snow when there was still an amount of snow in spring. Now, in Canada, some plants, some flowers do that. They're called snow piercers. It's a category of flowers. But we've made snow piercing species. It's the same species, just that these flowers pierce the snow when usually they would not. Okay, there's like one banner of season. That allowed us to know that the power of our super soil and our super forest solution, when we don't have snow to prove how efficient is the ground, this will still work elsewhere, okay? And that's what we're doing with our super forest.